All right, let's talk about the Java technical interview. If you're getting ready for one, you are in exactly the right spot. We're going to completely demystify the whole thing and break down what interviewers are really asking.
Yeah, I know. Just seeing those words can make your stomach do a little flip. Technical interviews are super stressful, right? But honestly, a huge chunk of that stress just comes from the fear of the unknown.
So that's our whole goal here. We're not going to just run through a list of questions and rote answers. No way. We are going to build a mental roadmap of the entire interview, focusing on the why behind the questions. You ready? Let's get into it.
Okay, every interview kicks off with the basics. Think of these first few questions as the warm-up lap. They're designed to see if you have a solid grasp of the Java ecosystem. You know, the foundation everything else is built on.
First up, a total classic. What's the real difference between the JDK and the JRE? It sounds simple, but it is absolutely crucial. The JDK, the Java Development Kit, that's your entire toolbox. It has everything you need to build an application. The JRE, or Java Runtime Environment, is just what's needed to run the app. The way I like to think about it is, you need the JDK in the factory, but your customers, they only need the JRE. So why is Java so incredibly popular? A huge part of it is that famous write once, run anywhere mantra. And this is the magic behind it. Your Java code doesn't get compiled for a specific operating system, like Windows or a Mac. Instead, it's compiled into this intermediate thing called bytecode. And that bytecode can run on any machine in the world that has a Java Virtual Machine or JVM installed. The JVM basically acts as a universal translator. Pretty cool, huh? So when your code is running, where does it all live? Well, it's mainly in two places. On one side, you've got the stack. It's super organized, super fast, but temporary. It's like a neat stack of plates for what you're doing right now, managing your function calls and local variables. Then you have the heap. This is a big shared space where all your objects get to live for the long haul. And the most important part to remember, the heap is what gets cleaned up automatically by Java's garbage collector.
Okay, so you've nailed the warm-up. Now the interview is going to shift gears. They'll start digging into the philosophy that makes Java, well, Java. This is all about object-oriented programming, or OOP. They want to see that you don't just know the words, you actually think in an object-oriented way. And that way of thinking is held up by these four giant pillars. You've got encapsulation, which is all about bundling your data up safely, inheritance, which lets you build new things from old things, abstraction, which is about hiding all the messy details, and then there's polymorphism. And you know what? Let's zoom in on that one.
Polymorphism sounds way more complicated than it is. It literally just means many forms, and it's an incredibly powerful idea that lets you write super flexible and reusable code. So, for example, you could have a bunch of different shape objects, a circle, a square, a triangle, and you can just tell each one to draw, and it'll know how to draw itself correctly. It's what makes your code so much cleaner and more adaptable.
Okay, pay attention, because this next one is a classic interview tripwire. What's the difference between an abstract class and an interface? Interviewers love this one. They're both used for abstraction, but here's the key. An abstract class is like a blueprint that might have a few walls already built. It can provide some default code. But a class can only inherit from one of them. An interface, on the other hand, is purely a contract. It's just the blueprint, no walls. But the great thing is, a class can promise to follow multiple contracts or implement multiple interfaces. All right, theory time is over. Now the interview gets really practical. How do you actually use all this stuff to work with data? This is where we get into the nitty-gritty of data structures. Here's a great why question for you. Why are strings in Java immutable? Meaning, why can't you change a string once you've created it? Well, it all comes down to reliability. Think about a hash map. It relies on the key, the thing you use to look up a value, staying the same. If the key could change after you've put it in the map, you might never find your data again. It'd be like your house key changing its shape every time you used it. Immutability guarantees things stay put. And here's another classic trade-off. When do you pick an array list over a linked list? The real answer is, it depends on what you're doing. An array list is basically an array under the hood, so it's crazy fast for just grabbing an element at a specific index. But if you need to add or remove things from the middle of the list a lot, oh man, a linked list is your best friend. You're just rewiring a couple of pointers instead of having to shift every single element down the line. Let's be real, code breaks. It happens. A great developer doesn't just write code that works on a sunny day. They write code that fails gracefully when the storm hits. This next part is all about that safety net, exception handling.
So, what exactly is an exception? It's your program throwing its hands in the air and yelling, "Whoa, I did not see that coming." It's some event that just completely disrupts the normal flow of your code. And a little fun fact for your interview: every single error and exception in Java descends from one single class, throwable.
And what happens if you don't handle an exception? It doesn't just vanish. It starts to bubble up. Think of it like a hot potato. It gets passed up from the method where it happened to the method that called it, and so on, all the way up the call stack, looking for someone to catch it. If it gets all the way to the top and no one's there to catch it, boom, your program crashes.
And finally, a tiny little syntax difference that trips up so many people: throw versus throws. Just remember this: throw is an action. You are actively doing it. I throw this exception right now. But throws, that's a warning. It's a declaration in your method signature that's basically a heads up to anyone who uses it, saying, hey, just so you know, this kind of exception might get thrown in here.
Okay, deep breath. We are now entering the advanced boss level tier of the interview. These questions about multi-threading and concurrency, this is often what separates the senior candidates from the juniors. This is all about performance and handling complexity at scale.
First off, what even is a thread? The simplest way to think about it is as a single path of execution. A program can have lots of these threads running at the same time, all working on different parts of a task. Like in your web browser, one thread is busy drawing the page you see, while another one is in the background downloading images.
And that leads to the key difference between a process and a thread. A process, like your entire web browser application, is its own little island. It has its own dedicated memory. But threads, they all live inside that process. And this is the crucial part: they all share the same memory. That's what makes them so efficient, but it's also why things can get complicated.
And here it is, the heavyweight champion of all threading interview questions: wait versus sleep. They both make a thread pause, but they are fundamentally different. Sleep is basically telling a thread, go take a nap for 50 milliseconds. And while it's napping, it holds on to any locks it has. But wait is all about communication. It tells a thread to pause and release its lock on an object so another thread can grab it. It then just waits until it gets a signal to wake back up. So remember, sleep is for timing, wait is for coordination.
So as we wrap this all up, I want to leave you with the single most important piece of advice. From the easiest warm-up question to the hardest threading problem, the interviewer is looking for more than just the right answer. They want to see how you think. How do you break down a problem? How do you explain your thought process? That's the real test.
And finally, remember this: an interview is a two-way street. When they get to the end and ask, so, do you have any questions for us? Your answer should always be yes. This is your chance to interview them, to show you're curious, and to figure out if this is actually a place you want to be. The tables have turned. So, what are you going to ask?